In this video, I want to have a look at sigma notation. So sigma notation is a concise way of writing different sums. So for example, we can write it like this. So this is the capital Greek letter sigma, and this means we're going to sum n squared from n equals 1 to n equals 5. So what that means is we're going to substitute in each number into here and add them all together all the way up until we get to 5. So we'd have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and we could simplify that down to 55. But you can see that writing it like this is much shorter than writing out this whole sum of numbers here, this whole series. And it's not too bad when we're only going from 1 to 5, but you can imagine if it was an infinite sum, so this was an infinity on the top, we couldn't write it all out. But even if it was just a really large number of terms, it's much nicer to write it out in sigma notation. So just one more example. Here we've got the sum of 2n minus 1 from n equals 4 to n equals 7. So we're going to substitute n equals 4 into there. So we'd have 2 times 4 minus 1 plus, and then we'd substitute in 5. So 2 times 5 minus 1 plus 2 times 6 minus 1, and then plus 2 times 7 minus 1. So what that's going to give us is 7 plus 9 plus 11 plus 13, which would simplify down to 40. So rather than writing out this whole sum, we can write it in sigma notation. So the reason we're talking about sigma notation is because we can use it in the context of sums of sequences or in terms of series. So if we have S10, that stands for the sum of the first 10 terms of that sequence. So we could write it as the sum of Tn from n equals 1 to n equals 10. So we could write that would be the first term plus the second term plus the third term all the way up until we got to that 10th term. And of course, if we had the sum to say 20, that would be the first 20 terms, we can change those numbers. But S10 stands for this sum. All right, so it's an introduction to sigma notation.